Okay, this is Mr. Urrego again. Now we're solving quadratic equations using square roots, but now we have imaginary numbers as part of the solution. So now we're going into the complex numbers. For that, I'm going to use 54, and we're going to start with 54. Okay? So 54 is x squared equals negative 16. 54, x squared equals negative 16. If you see the previous videos where we work with the square roots, the main thing that we need to have is the x squared by itself. As soon as we have the x squared by itself, then we can use the radical. So I'm going to apply the square roots on both sides, and as soon as you do square roots, you're going to have a plus or a minus as part of the answer, and I'm going to have a negative 16. Now, negative 16, I need to break it. But if you notice, I have a negative inside the radical. If I plug this into my calculator, it's going to give me a math error. How come? Because your calculators only work in the real numbers, with the real numbers. When you have a negative inside a radical, now you go into a set of numbers that are called the complex numbers. Okay, and I'm going to explain that briefly. So I have a square root of negative 16 complex numbers. Now the rule for the complex number is the following: when you have square root of negative 1, that's equal to I. I'm going to have an imaginary number. Okay, so with this negative 16, what I'm looking for is to break the negative 16 into the positive 16 times negative 1. Why? Because remember, I have the negative 16 inside the radical. So that means the 16 times negative 1 is going to be inside the radical. And I see on the top, this square root of negative 1 is going to turn into I. And square root of 16 turns into 4. So square root of negative 16 will be 4i. Simple as that. So now let's bring that answer over here to the left. X equals plus or minus 4i. Again, you have two answers. One positive and the other one negative. Okay? And that's how you solve a square root using imaginary numbers. Let's do something similar to that. Let's do 57. 5x squared. 5x squared equals negative 125. So 5x squared equals negative 125. Now, before you apply the square roots, remember the x has to be by itself. The x squared has to be by itself. So in that case, the 5 is multiplied. I divide both sides. I want to have the x squared by itself, which is right now 5 divided by 5 is 1. So I have 1x squared, which you don't have to write the 1. Now, negative 125 divided by 5, most of the time is negative 25. Now the x squared is by itself. Because it's by itself, now I apply, let me do that again. Let's do a different color. So I have x squared, I'm going to apply radical square root on both sides. The square root will cancel the square, so I'm going to have x equals. As soon as I do square roots on a quadratic equation, I do plus or minus. So I'm going to have plus or minus square root of negative 25. Okay, time to break the negative 25. Negative 25, like I said, because we know that we have a negative inside a radical, that's not possible. So now it's not possible on the real number, the set of the real numbers. Now we're going into the complex numbers. The complex numbers are written like a plus bi. You see the I here at the end? That's imaginary. Like our friends sometimes, imaginary. I didn't say that loud, I hope. So we have the complex numbers. Now I'm going to break that negative 25. Again, we always break the number into the positive number times negative 1. Why? Because I have square root of negative 25. That square root of negative 25 is square root of 25 times square root of negative 1. And we know now that square root of negative 1 turns into I. Square root of negative 1 is I. Square root of 25 is equal to 5. Okay? So my answer is going to be the following. From the right, I have that x is equal plus or minus square root of negative 25, which is 5i. Remember to break that into two answers always. My first answer is using the positive, so it's 5i, and the second answer is using the negative, which is negative 5i. And these are your two answers for the quadratic equation, positive 5i and negative 5i. To finish, let's do one with parentheses, which is basically the same process that we did before with radical equations. With quadratic equations. Let's do 60 or 61. Basically, they are the same. 60 here, my first step will be divide by 4 on both sides. Divide by 4, divide by 4. That'll be my first step. And then you do square root on both sides. The reason I'm doing this is because I'm not going to solve 60. I want to solve 61. I like that fraction. I know that's more confusing. So I'm going to use 61. Negative 1/4. R plus 1 equals 5. Negative 1 over 4. R plus 1. Negative 1 over 4. R plus 1. R plus 1 square equals 5, I think. Let's double check. Negative 1 over 4, r plus 1 squared equals 5. Negative 1 over 4, r plus 1 equals 5. Alright. Again, some people will get confused with the negatives. It's, oh yeah, that's subtracting, so I need to add 1/4 on both sides, and they will go crazy. No. That's a no. Remember, you want to check to see if there's anything between your number and the parentheses. Okay, as you can see, look over here. Is there anything in between those two? Nothing. That means they're multiplying. Okay, the opposite of multiplication, division. Okay, but this will be kind of confusing. Try to do it mentally. Okay, and we don't want to use calculators if we don't have to. Let's use that brain, please. So I don't want to use calculators, so right now that's confusing, and because I have a fraction that is multiplying my parentheses, I know that I can use the reciprocal. It's with a, yeah, reciprocal. Okay, getting confused now. So I'm gonna use the reciprocal for this. Let's erase all this thing. The reciprocal. If you saw any of the videos before, the reciprocal is basically flipping my fraction. Okay, flipping the fraction. So let me try to, oh my god, I'm erasing everything. So 1 over 4. The reciprocal of negative 1/4 is basically flipping the fraction, which is negative 4 over 1. Alright, and that's an ugly 4. Okay, negative 4 over 1. So whenever you have a negative, only one negative, erase it there and put it in the number on the top. Again, I only have one negative, so I'm going to erase it and put it the number at the top, so you don't get confused. Okay, so that means I'm going to multiply both sides by negative 4 over 1 by negative 4 over 1. Alright, Why? Because I know that negative 1 over 4 times negative 4 over 1 is going to give me 1. Or if you need me to do that, negative 1 times negative 4 is positive 4. 4 times 1 is 4. 4 divided by 4, 1. When I use the reciprocal, what I'm doing is I'm canceling the fraction. So let's continue. I know that with the reciprocal I cancel that fraction. Now my parenthesis is going to be by itself to the second power, and on the other side I have 5 times negative 4, negative 20, 1 times 1 is 1. Do I need to write this 1? Not really. So we can erase that. Because negative 20 divided by 1 is negative 20. Now, my parenthesis that has the exponent is by itself. Now I proceed to do square roots on both sides. The radical will cancel my square. So I'm going to have r plus 1 on this side. And as soon as I do radical square roots on both sides, I'll have a plus and a minus as part of my answer. So I'm going to have plus or minus square root of negative 20. Like in the previous problem before, I'm going to take that negative 20 and I'm going to break it into what? The number itself, which is 20 times negative 1. The reason square root of negative 20 is square root of 20 times negative 1. But this, oh my god, I did something wrong here. Okay, but this is square root of negative 1 is I. Now the 20, we need to break the 20. 4 times 5. 4. 2 times 2 means 1, 2 is coming out. Is this 5 coming out? Nope. So it stays inside the radical. And I have my I. So square root of negative 20 here is equal to 2 square root of 5i. Two ways how to write this down. You can write 2 square root of 5i like I did over here, or you can write 2i square root of 5. Either one of those notations is fine. Most books, I don't know, they have it half and half. I would recommend the second one, this one, because some people will do this. They will do 2 square root of 5 and they will extend the radical inside the I. I'm sorry, on top of the I. And this is a horrible mistake. That's a no-no. So you don't want to do that. So that's why I recommend to do the second answer. So let's bring that over here. So I have r plus 1 equals plus or minus. Now I know that I have this answer. So I'm going to have plus or minus 2i square root of 5. From there, break it into 2. Sorry. I'm not ready to break it into 2. You see that? I'm skipping a step. Hopefully you notice that. My step that I miss is I need to leave the r by itself. And I have this 1 in there. So the 1 is positive, so I subtract. And I'm going to have r. 1 minus 1 cancels out, is 0. Again, remember, you can't combine the negative 1 with all that expression because you have an I and you have radicals. You cannot combine them. So what you're going to do is, whatever has the plus or minus, normally I write it at the end. Plus or minus 2i square root of 5. Let me black over here so we know that. Oh, that's like a face. Look at this, like an ear. So, sorry about that. Whatever has the plus or minus, like I said, I push it to the end. I move it to the end, to the right. Okay? And this number that I'm subtracting, the negative 1, I put it in the beginning. Okay, so I'm going to have r equals negative 1 plus or minus 2 square root of I. I'm sorry, 2i square root of 5. Now, we are ready to write the two answers. Okay? One with the plus, the other one with the minus. And let's see if we can stretch this out a little bit more. Yes. So, first answer, r equals negative 1 stays the same. I'm going to use the plus 2i square root of 5. The second answer, r equals, the negative 1 stays the same. Now I'm going to use the negative. So it's going to be negative 1 minus 2i square root of 5. And those two are my two answers for these quadratic equations. Okay, I hope you got that. Review please, study. Thank you.